Welcome to The Explainer. Today, we're talking about a fundamental number in mathematics called the MRB constant. But here's the twist. This constant wasn't discovered by some ancient Greek genius or a tenured professor. Nope, it was found back in 1999 by a construction worker with a home computer. All right, let's get right into it. And I know that sounds like the opening to a movie, right? But it's the completely true story of a number that was, for all of human history, just hiding in plain sight. So to really get a handle on this number, we've got to meet the man who found it, Marvin Ray Burns. He wasn't a professional academic, just an amateur mathematician driven by pure curiosity. Burns's story is it's not your typical academic journey at all. He was a self-taught hobbyist, had an associate's degree, and worked in the construction trades. But starting around 1994, he just poured his free time into mathematical exploration. And his motivation was simple but really powerful. He wanted to make a lasting contribution to the field he loved. Okay, so what's super interesting is where Burns was looking. He wasn't digging into some super complex high-level theory. He was investigating a mathematical series that when you first look at it, seems pretty simple. But the way it behaves, it's truly bizarre. So this is the series he was tinkering with. It's an alternating series, which means it flips back and forth. It adds a term, then subtracts the next one, and so on. And the terms themselves, k to the power of 1 over k, that's the unusual part. See, as k gets bigger and bigger, each of those terms gets closer and closer to 1. And that little detail is the key to all its strange behavior. Now, usually with a series like this, you'd expect the sum to, eventually calm down and converge on one single stable number. But this one, it just doesn't. As you add more and more terms, the sum never actually stops moving. It's what mathematicians call a divergent series. And this table just shows that wobble perfectly. I mean, look at the partial sums. It goes from -1, jumps up to positive 0.4, then dives back down past -1, then back up again. The sum is just constantly bouncing back and forth, oscillating, but never really landing on one specific value. But here's where it gets wild. As Burns kept calculating more and more terms, he noticed something incredible. This wobble wasn't just random noise. The sums were actually clustering, or as mathematicians say, accumulating, around two very specific, very stable points. It was like they were being pulled toward an upper value and a lower value. And get this, they were separated by exactly 1. The series was basically dancing between these two hidden numbers. And right there, inside that strange wobble, Burns had found his treasure. So, in the formal math language, this upper point is called the limit superior of the series. And that upper accumulation point, that number the sums kept trying and failing to reach, it wasn't just some random number. It turned out to be a completely new, previously undiscovered mathematical constant. And there it is. It was named the MRB constant for Marvin Ray Burns. After he confirmed with a professional mathematician that, yep, this was something new, Burns had officially made his lasting contribution. But, discovering a number is really just the beginning. Understanding it, that's the real challenge. And the MRB constant is absolutely surrounded by these deep, fascinating mysteries. Think about it. We have these really elegant ways to write down constants like pi. But for the MRB constant, we've got nothing like that. Finding a simple, what they call a closed-form expression, that would be the ultimate prize. It would reveal some deeper structure. But the question is, does one even exist? Or is this number's identity forever tied to that infinite, wobbling series? Okay, so what about this? Is it irrational? An irrational number, like pi or the square root of 2, has a decimal that just goes on forever without ever repeating a pattern. We have millions of digits of the MRB constant. And yeah, they sure look random. But that's not proof. Actually proving it's irrational remains this elusive goal for number theorists. And what about its connections? Is this number just some isolated island in the mathematical universe, or is it part of a grander interconnected web? Could it have some hidden relationship with other famous constants, like pi or e? Man, finding a link like that would be a monumental breakthrough. And the crazy thing is, to this day, the answers to all of these questions are unknown. There's still wide open problems in number theory, which makes the MRB constant a truly enigmatic figure in the world of math. So hold on. If we don't have a simple formula for it, and we're not even sure if it's rational, how on earth do we even calculate its value with any kind of precision? Well, you could use the brute force method and just add up the terms one by one. But the series converges so incredibly slowly that you'd need about 1 million terms just to get 6 decimal places. I mean, wow. Thankfully, there's a much better way. Acceleration algorithms. Instead of just adding, these super clever programs analyze the pattern of the wobble itself. They predict where the series is heading and converge on the limit like crazy fast.
And because of these advanced techniques, the quest for precision has gone way, way beyond what Burns could have even dreamed of back in 1999. As of 2022, the MRB constant has been calculated to over 6.5 million decimal places.
So when you boil it all down, the story of the MRB constant is so much more than just a new number to add to the list. I mean, it's a perfect example of modern computer-assisted discovery, right? It shows how powerful tools and just plain old human curiosity can work together to uncover fundamental truths. It's proof that you don't need a PhD to make a profound contribution. And it's this beautiful reminder that there are still these deep, unanswered questions hiding in what look like the simplest corners of mathematics. And really, at its heart, this is a profoundly human story. It's a testament to the power of one person's passion, a hobbyist who, driven by an interest he had since he was a kid, just decided to explore the unknown and ended up discovering something entirely new. And all of this leaves us with a final, fascinating thought. What other fundamental truths, what other hidden patterns are still out there, waiting to be discovered? Not in some billion-dollar lab, but by the next curious mind with the computer.